Hey folks, hope you're doing well. My name is Spencer and I'm an engineer here at Sidero Labs. It's been a little while since I've done one of these hack sesh videos. And it's, nighttime here, the family's in bed. So I figured it might be a nice little opportunity to come in and do some night hacks. So let's check out what I want to show today is called Cubespan. So Cubespan is a new feature that's coming in Talos 0.13, of which there's a beta release and a GA release should happen this week. Um, so Cubespan is essentially built-in support for WireGuard tunneling right inside of Talos, and it's super easy to configure with machine configs and things like that. So it makes it really easy to create a truly hybrid Kubernetes cluster. So, across multiple clouds, from your DC into the cloud, from your home environment out to the, wherever, all that stuff kind of works, and it's pretty cool. And I think it's going to be a big deal for people. So I wanted to spend a little time doing some of this longer form, hack session stuff and show that stuff off. So if you take a look at the architecture diagram I've got on the left here, it's the top of my screen, but on the left on what you're seeing on the recording, this is what I want to create today. So I want to do a control plane in Amazon fronted with just a couple load balancers and a private subnet. And then I want to add some worker nodes into a public subnet there and do the same in GCP. So what we'll see is essentially all those nodes join the cluster. They are, you can use Talos CTL against them all. And they are all kind of part of one mesh and one Kubernetes cluster. And that is pretty awesome. So don't get too hung up in the architecture diagram here on, these arrows and stuff. This is really just my mental map of trying to understand how Cubespan worked from some of our networking folks and just, making sense of it all. So this is my own mental model and it's kind of what I'm working off of, but don't get too hung up on it. So first, what we'll need to do is spin up some stuff in Amazon. So this is going to be a little pointy and clicky just because I don't feel like going to look up the CLI commands for all this stuff. So what we'll need is a couple security groups. We'll need one for our load balancers, one for our control plane nodes, and one for our worker nodes. So we're gonna blast out 3 security groups here pretty quick. I'm gonna use some of this. I've done this, ran through it at least to make sure it kind of worked the way I wanted it to. So I'll be doing a little bit of auto completion here, but I'm going to create a load balancer security group, and this is going to allow Kubernetes and Talos CTL from anywhere. So that's convenient that that went ahead and filled it in for me. So the Kubernetes port we use is 6443, and that's going to allow it in from anywhere. And then again, 50,000, allowing in from anywhere. So, you could lock these down more. I just wanted to make sure that I can, I could lock them down to my, local network, things like that. But, I wanted to make sure I can get to these pretty easy and show it off. So there's the load balancer security group. Let's do our control plane security group. So same deal, Spencer Talos, CPSG. And this allows from the load balancer to CP nodes. And again, it'll be the same ports, 6443. And then here, I'm going to use a custom SG and then say I want to only allow from that security group, that it will be associated with the load balancers. So same deal, again, 50,000. Source SG, and then pick my security group. Perfect. And then one more real quick, like Spencer Talos worker SG. So the only thing this will allow is the WireGuard port. So, you know, this is all WireGuard stuff. So we have to expose the WireGuard port so that we can form a mesh. So you've got to have at least kind of one external node in your cluster as it stands right now, just because that's the way, you know, WireGuard and NAT traversal and all that fun stuff works. And we are working pretty hard on even improving that and looking at turn servers and things like that, that we can, you know, really allow people to do some pretty complex networking stuff. But for now, we will create and allow in this WireGuard port. And I'm going to look back at my architecture diagram. 51820 is what we want. So 51, can't type, 51820, and that's going to be from anywhere. But that will be the only port I allow in to these workers. So security group created. Now we can go and create a couple of load balancers. So again, I wanted a load balancer for Kubernetes, one for Talos CTL. I chose to do two different ones for a couple of reasons. The new, oh, get out of here. They changed this since like earlier today. That's fun. The newer load balancers I've got kind of a beef with right now. They don't seem to let you associate a security group with them, and then so that you can lock down your like control plane nodes and say, I only want to allow traffic from my security group or from my load balancer security group. So it's kind of on my bad side right now, but we're going to choose a classic load balancer to get around that. And as such, we will have to create two of them, one for Kubernetes and one for Talos. So Spencer Talos, Kate's LB, and this is going to be the Kubernetes API, if you couldn't guess. 6443. And so you can actually add multiple ports here, but again, it only allows you to do one health check. So it just gets a little squirrely. I will associate that load balancer security group there. That's all fine. I'm gonna also lower this threshold just so it comes online a little faster. Skip adding instances for now. Serve Talos LB, and we will create that cat, and then we will do the same for the Talos load balancer. I'm just going to call it API LB because Talos seems weird, but yeah, so 50,000 again, 50,000. Assign it that same load balancer security group. Lower the healthy threshold, and we're off, I think. So we will create that load balancer. So that's both our load balancers created. That gives us all the info we actually need to generate our Talos machine configs. So we can go ahead and do that. I'm doing all this manually just to make sure that I kind of walk through all of it and all the setup that actually is needed kind of under Talos and, you know, in Amazon. So, you know, this is a little easier if you're using like cluster API or something like that to create Talos clusters. But anyway, so Talos CTL gen config is the command we're going to want here. I'm going to give it a help flag so we can look at some stuff real quick. I'm mostly interested in these last three flags to pass in with docs with examples. Those are both just in our machine config when we render it. We will include all that stuff by default, so it's really nice and easy to kind of reference and know what knobs you can kind of tweak. For once in my life, I actually kind of know what I'm doing going in here. So I'm going to turn those off. And then the last flag with Cubespan, I'm going to set the true. And that's going to inject those, the Cubespan patches that I was talking about in our machine config. And I'll show you those. They're super easy. There's not a whole lot to them. But what we'll do is Talos CTL gen config. And I'm going to see if I can copy and paste here. With docs false, same goes for with examples. And then with Cubespan is going to be true. And then after that, you give it a cluster name. and then a Kubernetes endpoint. So for us, that will be our load balancer DNS. So I'm gonna go head out here, Kate's LB, scoop that load balancer DNS name up, pop it in there, and that's also gonna have port 6443. So that's all we need to gen a config. It's really fast, and then I'm gonna make one small tweak after the fact to the control plane YAML, and I'll show you the Cubespan stuff while we're in there. So what I'm doing is I'm going to inject the API load balancer as an extra cert SAN for this machine, and I'm doing that so that Talos CTL is, the cert knows about that DNS name, and it's in the cert SANs, and and I can actually talk to it with Talos CTL. So we're adding that in there, and then as you can see, kind of right here in the machine section of our config, there's a network place, and all you do is say, I want Kubespan-enabled true. And that's all you need to do to enable Cubespan. Further down in the cluster, we also have a discovery key. And this basically tells it that while using Cubespan, we want to use our public discovery service. So as part of the Cubespan launch, we're offering a discovery service so that clusters can come up and know where its peers are, and how to contact them and how to set up its mesh. So that's really cool. We also offer, we also give you the ability to do that on-prem, host it yourself, whatever you want to do. You don't have to use the public service. We've thought about that already. But it is an option, and that's what we're going to use for now, because hey, that's a little easier. So that's all I needed to change in here, though, was the one cert SAN. And now we're ready to, I think, create some instances. So what I'm going to do is I'm going to head out to talos.dev. I'm going to slap that hamburger button and then go to the 0.13 docs. And then look in Cloud Platforms AWS. And I'm going to steal this really nice one-liner here, paste that into my terminal. We publish a cloud images.json every time we do a release of Talos in our release artifacts. And the really nice thing about that is you can pipe it right into JQ and get the AMI that you're looking for right away. So I'm going to update the version to be beta 0 because 13 is not out yet, even though it says it is, even though that example gives that in the docs. And then I'm in US West 1 right now, so we will update that as well, and that will return our AMI that we'll use for this. So now, out in Amazon, we will launch an instance. And so I put that in. It's a little confusing when you first look at it. It kind of looks like there's no results, but you have to go to community AMIs first. I don't know why their UI works that way, but hey. Head to community AMIs, give it the AMI ID, you'll see it. And then we'll select a large instance. Again, nothing too crazy here. But I do, I forgot to say this earlier, but in my VPC, I did create, let me talk about this for a second. Quick side note, I did create a public and a private subnet in my VPC to use for this stuff. And that's pretty straightforward. It's, whatever, it's whether or not, the instance that comes online gets an external IP. Is really the only difference there. The only other difference is for the private subnet, I had to create a custom routing table. And as part of kind of that, I had to create a NAT gateway so that it's basically, a gateway that sits between the public and the private subnets, and it gives a path to the internet, essentially. So to make sure that those private nodes can get to the internet, I created a NAT gateway and then created a route table that made use of that gateway for my private subnet. So did a little bit of pre-work there, and I forgot to mention it earlier, and I'm sorry. But yeah, so I do have these two subnets, public and private, that we're going to make use of. So back to creation of an instance, I'm going to use the private subnet for this control plane. So I'll say private A, fine. And the only other thing I'll need to do is add in my control plane YAML. So what I'm doing is over on the side is just I opened VS Code and just so I could copy paste that easier. So here we go. That's pasted in. Storage should be fine. I'm going to add a name tag just because I never know when things actually get named or not in Amazon. We'll call it Spencer Talos CP0. So my first control plane node. We will select our CPSG. So the one that only allows traffic from the load balancer. And then we'll say go. Yeah, we know that SSH isn't open because we don't have SSH because we don't like it. So yeah, no SSH. That's all fine and good. Don't need a key pair either. So that's our instance running. So cool. Let's go take a look at some things, I guess. In our files we just generated, there's a Talos config. So what I'll do is I'll export the Talos config environment variable to be that local path so that when I use talosctl, I don't have to give it the -- Talos config flag every time. And then after I do that, if you take a look at it, it defaults to using localhost as the endpoint, just because we can't really predict when you gen a config what the Talos endpoints will be. So we will update that by saying talosctl config endpoints, and we'll give it the path to our API LB. And that's just gonna, not developer mode. Okay. That's just gonna tell, when I use talosctl, that's where we're gonna go to, talk to our nodes. So the other thing I'm gonna do while I'm out here before I forget is add these control plane nodes to my load balancers. Well, my one control plane node, I guess. I'll add it to my load balancers, and that should come online pretty quick, at least in terms of the API LB. And as soon as that's in service, we'll be able to talk to it. Perfect. Let me grab its IP. And then what we can do is talosctl dmessage -in and give it that IP. So I can see all the dmessage output. It looks scary right now because Kubernetes is still coming online. But the bit that's important in here is kind of this line right here that says, hey, is this the first node? And if it is, run talosctl bootstrap. Like I said, if you're using our cluster API stuff, you don't really see this because we handle that flow for you. But because I'm doing this manually, I do have to pick my first node to be the one that is my etcd initializing node and that kind of thing. So what I'll do is I'll just say quickly talosctl, give it that node IP, and then bootstrap. And then again with the dmessage, you'll see that etcd is starting up. Kubernetes is coming online, and then that means that our health check for our load balancer for Kubernetes should be up here in just a second. So what I'll do then is talosctl kubeconfig. And override my old one, and then we'll say kubectl get nodes. Not quite there yet. Yeah, so this can take a second, just because, things are still coming up. The kubelets, all the static pods got laid down, so the kubelet's still trying to handle all that, I'm sure. Kind of see where we are. Yeah, we're creating static manifest stuff, so we should be pretty close here. Yeah, there's in service. Cool. There we go. Okay, so API server is responding. No nodes yet because it's not even that far. The kubelet hasn't even registered itself. but we got in there pretty quick. So that will turn itself around pretty soon. And that is our control plane node online. So let's let that do its thing in the background. While that's still coming up, I'm going to launch a worker. Just because I'm being impatient, I guess. But, you know, here we are. Okay, same AMI, and then most of this is going to be the same info. The only real difference is going to be that I'm going to choose my public subnet here. Sorry, just a second. I'm going to pause real fast. I think my camera, my camera timed out. Hang on just a second. Okay, back. Sorry about that. I need to come up with a better system than a rubber band to hold my camera shutter down. Fun times. Okay, so continuing on. Public subnet, that's all fine and good. And then I think all we need to do is paste in our worker YAML. So let me go grab that out of VS Code. And we will pop that bad boy in there. Again, storage, fine. Give it a name tag, I guess. And then we will select our security group that allows in 51.820. That's it. No SSH. We know. Keep our either. Cool with that. That's it. So let's get nodes here. Control plane's up and ready. Perfect. Now what we can do is we can see probably almost the exact moment when the worker node, the Cubespan mesh is formed. If we do members -w. Nope, get members, sorry. Gotta be too fast. So that shows our one member, a control plane node, as the worker boots and checks in with the discovery service and sees that, there it is, that there is another node for it to form a mesh with. It will go ahead and do that. So perfect, checked in, awesome. That is pretty much all we need to know. I can get nodes as well. It's probably still coming out. We're probably still not even that far yet. The discovery stuff happens pretty early in our boot process. Yeah, so worker nodes up, checking in now. And then what I'll do is let's do a GCP node, I guess. That sounds cool. So let's go out to GCP. I'm gonna head to instances. Here I've already opened up the firewall again to allow WireGuard or that 51.820 port. It should be pretty much, I think, all you have to do out here. That's the only thing I've really gone and done. The other bit of pre-work you'll have to do is out in the Talos docs. If you head to the GCP section, GCP doesn't make it easy to, publish an AMI, right? Like Amazon does. It's not something we can kind of release into the community easily, at least as part of our release process. So what you do have to do is download it from our Talos assets in our release page in GitHub and upload it to your local bucket and make an image out of it. But it's really not hard. It's seriously like a GSUtil copy and then a register of that image, right? So it's super easy. It takes just a second, but I went ahead and did that too, just so we didn't have to sit here and watch. So yeah, so let's create an instance here. I'm going to use the CLI for this one because I actually have it. I know I have it in my bash history. And when you do it through the GUI in Google Cloud, it tries to mangle our machine configs a little bit. So we're going to do it through gcloud, the CLI. And what I'm going to do is I'm going to tweak some of this. I'm going to make this again an external IP. It's going to have an external IP, and it will be on a security group that allows the WireGuard port. But create. I'm going to say this is called Spencer Talos Worker GCP 0, just so there's a little differentiation there and it's easier to see. Even though the Amazon stuff will be IP dash blah 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 as the host name right now. Yeah, and then I'm going to give it that Spencer Talos image that I uploaded, and then metadata from file is this local worker.yaml that's in this directory. The only bit there is that you need to use the user dash data key in this metadata from file deal. So it's under a user data key and then all of this text. So yeah, so that's it. Let's create an instance there. Perfect. Okay. That's all good stuff. Those warnings are fine. Yeah, so we should be in business here. Let's do a get members again and see if we're already there. Man, that was fast. Okay. Yeah, so we already have our GCP worker as part of our members as well. I gave it the watch flag, so it kind of scrolled a little bit on me, but I don't know if I zoom out, that's probably a little cleaner to read, ish, not really, but kind of. Yeah, so there's my control plane node, the first one, and then one worker, and then my GCP worker. So beautiful, everything's joined in. The real test, I guess, is going to be if I can get to that guy over teloctl. I may actually want to see first Cubespan, and this is just some troubleshooting stuff that we built in, which is kind of nice to know about. Here statuses, and I can see that that GCP node is in an unknown state right now, which just means that like the mesh isn't fully formed up, right? So we know about that node, but we don't know if it's up, and now we know it's up. So perfect, we should be able to talk right to it. That's beautiful. And I think we can actually talk to it over any of these addresses that it publishes, but let's get members one more time. And I can see, yeah, it knows about this private, I guess it knows the internal IP, you know, from GCP. So let's see if we can demessage against that internal IP. And if so, then that flows over WireGuard and we are off to the races. teloctl-in demessage-in paste the IP demessage. Beautiful. Okay, so perfect. That's exactly what I want to see. We're going over our WireGuard tunnel. Anytime you do teloctl, it goes through your control plane nodes, right? So those control plane nodes then proxy traffic to your other nodes, if they're not the node you're on, to get, you know, where you're going, right? And the info you want out of teloctl. So me doing a demessage against that node goes through the WireGuard tunnel to GCP, to that GCP instance, and gives it all that stuff back. So that's perfect. That's exactly what we want to see. And if I get nodes, I also see that my GCP node, of course, is joined. And all of my stuff is kind of up and running, right? So that's really cool. And that's kind of all you have to do, right? So what we did was, just to recap a little bit, we created a whole bunch of stuff, but the gist of it was we created a control plane and a private subnet, worker nodes in AWS and worker nodes in GCP. And we're able to join all those to the same Kubernetes cluster, as well as the same WireGuard mesh, and, you know, being able to get that info with kind of get members and teloctl. Oh, good grief, can't type. Being able to get members and see all those things as part of a member, as part of our member list, and seeing that. With the Cubespan peer statuses that our mesh was fully formed against all those nodes, It's exactly what we want to see, and I really think this is going to be a huge game changer. The use cases I'm pretty interested in are folks that are wanting to do, with bursty workloads and things like that, where they're wanting to do kind of Sidero clusters, or Talos bare metal clusters that they built with Sidero in their data center, and being able to take that and burst it out to the cloud when these bursty workloads come in, right? And things are kind of hectic and they need more, they have essentially an extension of their data center in Amazon or GCP, right? And I think that's a really, really compelling idea, and it's what people have always wanted from hybrid. That's never really felt like it existed like it should. Um, so I'm really excited about this, and I hope that this was a helpful video. All of this Cubespan stuff is, I'll put up some links here. All of this Cubespan stuff is coming out. It's already in the beta. If you want to use it, if you want to try it out, go for it. All of it's going to be like kind of officially released at KubeCon next week. So there will be a big push from our side at Sidero Labs on that stuff. If you're going to be at KubeCon in person, stop by the booth. We'll give you a demo of it. Myself and a few other people will be there. Additionally, there's the whole virtual booth thing, and we'll have that staffed as well. And we can certainly do a demo of Cubespan for anyone who's interested there too. So hope this helps. Hope this is a fun little hack sesh, and I hope that you got some stuff out of it and already had the wheels turning on how you can make Cubespan do some pretty cool stuff. So ping me in our Slack if you need me, have questions, anything like that. Thanks for your time, and take care of yourselves. Bye.